Have you ever wondered why time seems to move differently depending on where you are or how fast you're moving? Welcome to the fascinating world of time dilation, a phenomenon predicted by Albert Einstein's theory of relativity. In 1905, Einstein revolutionized our understanding of space, time, and gravity with his special theory of relativity. One of the most mind-boggling consequences of this theory is time dilation, the idea that time doesn't pass at the same rate for everyone, everywhere. Time dilation occurs when an object moves at a significant fraction of the speed of light or experiences a very strong gravitational field. According to Einstein's equations, time moves slower for objects that are moving faster or are closer to a massive object like a planet or a star. For example, imagine a spaceship traveling close to the speed of light. To someone aboard the spaceship, time would seem normal, but for an observer on Earth, the clocks on the spaceship would appear to tick much slower. This difference in the passage of time is time dilation. Einstein derived time dilation from the core principles of his special theory of relativity. The theory is built on two key postulates. First, the laws of physics are the same for all observers, no matter how fast they are moving relative to one another. Second, the speed of light in a vacuum is always constant, no matter how fast the observer is moving. From these principles, Einstein derived an equation that shows how time slows down as you move faster. The faster you go, the more time slows down for you compared to someone at rest. The equation is simple but profound. It tells us that time dilation becomes significant only when you are moving close to the speed of light, where v is your velocity and c is the speed of light. Time dilation isn't just a theoretical concept, it has real-world applications. One of the most well-known examples is the Global Positioning System, or GPS. GPS satellites orbit Earth at speeds of about 14,000 kilometers per hour, and according to Einstein's theory, time actually passes slightly faster for them than it does for us on the surface. If this difference wasn't accounted for, GPS systems would accumulate errors of up to 10 kilometers per day. Another example is astronauts in the International Space Station. They are moving at around 28,000 kilometers per hour, and according to relativity, they experience time at a slightly slower rate than people on Earth. However, the effect is so small, only about 0.07 seconds per day, that it's negligible. Time dilation also plays a role in particle physics. In particle accelerators, particles like muons travel at speeds close to the speed of light. These particles decay very quickly in our normal frame of reference, but when traveling at relativistic speeds, they live longer because time is dilated for them. But time dilation doesn't just happen with speed. Einstein's general theory of relativity tells us that time also moves slower in stronger gravitational fields. Near a massive object, like a planet or black hole, space-time is warped, and time moves more slowly. This is called gravitational time dilation. Near a black hole, for example, time slows down dramatically. As you approach a black hole, time slows so much that, from an outside observer's perspective, an object falling in would seem to freeze at the event horizon, never actually entering the black hole. So, how does time dilation impact us in everyday life? For most of us, the effects are too small to notice directly. But as technology advances, understanding relativity becomes more important, especially for things like GPS, satellite communications, and even future space travel. For astronauts traveling to distant stars at relativistic speeds, time dilation could mean that while only a few years pass for them, many decades or even centuries could pass on Earth. This could one day be crucial for long-term space exploration. Time dilation may seem like a strange and distant concept, but it's a fundamental part of how the universe works. It shows us that time is not a fixed, unchanging quantity. It's flexible, malleable, and affected by speed and gravity. So next time you think about time, remember, whether you're in a high-speed spaceship or standing next to a massive planet, time is not as simple as it seems. And who knows, in the future, we might just be able to use time dilation for some of the most incredible journeys humanity has ever undertaken.